Jason, founder of Arize. If you all don't know me, Arize is an evaluation observability platform. And feel free to, I think everyone knows you, Jerry. And feel free to intro, or John, feel free to intro yourself.
Hey guys, I'm Jerry, co-founder CEO of LlamaIndex. For those of you who don't know, LlamaIndex is a dev tools company helping AI engineers build LLM applications over their data. So everything from RAG to agents, part of this class. But yeah, excited to be here.
I'll give a quick one. I'm our third speaker today. I'm John. I'm a developer advocate here at Arize. As Jason mentioned at the beginning, I've been, over the past few weeks, building out a lot of agents in different frameworks, including workflows. And so I'm going to kind of pepper in a couple of bits that we have as we go through, and we get more into the weeds on some of the examples we show and things like that. I'll jump in for some of those. But you'll hear mostly from Jason and Jerry today, but just wanted to be able to add in a couple takes from those projects that we had as we worked on those over the past few weeks.
Cool. So agents is a hot topic. We do have AutoGen coming, Chief from AutoGen coming in a week or two. So please join us for that. And there's also a ton we're adding to kind of a course around this, GitHub repos that show how to build some of this stuff in the different frameworks. And I'm excited about workflows. I feel like the team really came away with a great impression of, and so we'll kind of dive into it today. First off, I hate to do this. I see this all on Twitter, and what is an agent? And I think a lot of people have a lot of different ideas in their head. There's this idea of this autonomous thing that's going on and doing something. I think most of us, I think that does fit in agents, but I think most of us have a much simpler kind of view of what an agent is. And this is kind of my take, and love to get Jerry's hot take on it. But I mean, you'll hear some folks, you'll hear people out there saying, control flow of application by an LLM is an agent, and it's a little bit abstract to me. I mean, I think what I see more nuts and bolts is like we'll talk a little bit about today, but this concept of an LLM router, which is an LLM making a decision or function call, which is control flow, but more specifically what we see, and then something around that function call, that path, that branch that accomplishes something, and it could use an LLM or it just might use APIs directly. So that's where when you hear control flow, this is where it comes from. I think less abstract. Typically, we're like LLM router plus some actions are typically what we're calling agents, which is much simpler than I think a lot of people have in their heads, which is this autonomous thing that's iterating constantly, which it could be, but this is the simpler definition I think most of us have. Any thoughts from this, Jerry, John?
Yeah, I mean, I have even a bit more of a general definition. It's just a program with non-zero LLM calls in there. And I think it's basically just like, you're writing code in Python and TypeScript and Java or whatever. And then, in the middle of that program, you might want to make an LLM call. And so the simplest, which, you could argue is not agentic at all, is just like you use it to like summarize a piece of text, right? And so you're not making decisions from that, you're just generating something. But that's like one LLM call. Some of the stuff that Jason is mentioning here is basically like using an LLM router is basically an if-else. You're kind of replacing the if-else with like automated decision making, using the LLM. But if you write it in the program, it's basically just like if LLM.output equals something, do this. If LLM.output equals something else, do that, right? And then a lot of like the agent architectures you see out there, like function calling, React loop, like tree of thought. It's basically just like some nested while loops, but with like LLM calls. So I think maybe, I mean, there's a philosophical question, which I don't have to get into here, on like why we build workflows and why like, an agent framework exists. But like, and what's the difference between with like a traditional program? I think part of it is like an LLM call is stochastic. And so they, like given some input, you don't quite know what comes out on the other side. And so there might be a deeper need to like inspect, observe what's going on, kind of why Phoenix and Arize exist. And then there's also the fact that they take a long time. And so that's partly where there's like optimizations you might want to run in the program where maybe you can parallelize calls, right? Instead of like doing everything sequentially. And then everything else, like there's more stuff too, but like really kind of a lot of that boils down to just like some key, maybe slight differences between, having LLM calls versus just like a program.
Yeah, and it's funny. I think there was this. I think it was just yesterday. There was someone dropped this on this Twitter. I think Swix's comment was something like, a while loop with an LLM is an agent. So you'll hear differing opinions. Like even within probably me and Jerry here. Like I kind of lean the direction a single LLM call probably the term agent might not be useful for it. But even within that, even within this group here, where there's debates on kind of what is meant by this term. Well, let's not get lost here. Let's talk about what like what workflows is, and we did do our team kind of looked at uh, you know uh, agents with graphs. So this would be like a lane graph type approach with nodes and edges versus kind of workflows being event based. And John, you've kind of built in both of these. Any quick takes on kind of like the feeling of one versus other?
Yeah, and I promise I'm not just saying this because you're here, Jerry, but I do feel like I kind of fall more on the workflows, event-based architecture side as preferred. And the reason for that from my side is just because after building with both of them, with workflows, you can kind of think in terms of steps, and each step as you're going through your program is fully contained in a way. So you can kind of compartmentalize almost as you're building. You can say, okay, I'm going to focus on everything in this particular step, figure out all that, and then I'll set up the events to trigger outside of that. But you almost think of like the steps individually, and then you can move between those as you want to. Versus with the graph approach, you're kind of thinking more in terms of nodes and edges. You have to define each one, and depending on what framework you're using, you might have conditional logic that lives on the edges too. And so you have to kind of build the graph in your head as you're going, as opposed to workflows. You can be like, okay, let's just build the full router step, and then I can forget about what's happening there, move on to my tool calling step, and kind of just it's a little bit more logical in my setup. It's my own preference, but I think that I find the workflows event-based architecture to work a little bit better for how I like to program.
Yeah, I mean, awesome to hear that. I mean, also, but I also do trust you guys for like the unbiased takes. So like in parts where, workflows need feedback or improvement, or for you folks who try out like workflows, would love to see like what are some of the additional features you guys are using.
Yeah, absolutely. And I think I guess one question for John, because you've kind of done a lot in both here. Do you feel like did you have to build the state machine in your head as you're thinking through the event-based one? I guess you kind of had it already because you're kind of thinking of the layout, but like this like in one case there's almost a state machine you're building or a flow that you're building from nodes and edges versus kind of in another case you're just thinking about things in terms of events.
Yeah, I think that I did have to have it in my head and
Yeah.
kind of figure out like you do have the map in your mind in
Yeah.
some way, but it's
Okay.
just that whether you're holding the whole thing in your mind or you can break it up into pieces that you kind of come between the different steps.
Got it.
There's other pieces we'll get into too of like I think I had some trouble with like the async side of things, and we can talk more about that too and some areas there. But I think
Yeah.
definitely from the event perspective, I like this approach a little bit more.
Okay. Cool. Um, so the thing what we tried to do, I think the team wanted to take like an idea of an agent which had a loop and maybe some actions or skills off of a router, really a simple form of an agent, as simple as we could kind of can make it, but somewhat useful. And then try to do it in a bunch of different frameworks and get a feeling for like, okay, what does it feel like to create this in AutoGen? What does it feel like to create a workflow? So John's kind of been doing that. I think it's pretty, we'll have more kind of releasing the code along with it in the GitHub repositories. But this is kind of the layout. And in this case, it's event-based, the dots are kind of events between the blocks here. Obviously in LangGraph, it's going to be nodes and nodes and edges, but this kind of gives you all the layout of kind of what this looks like in the frameworks. Anything else to add to this, John? Want to describe maybe a little bit of what the goal was?
Yeah, I think the goal is to have kind of an agent that works across a bunch of different frameworks that we can test out as well too. And so with this one, I think we tried to go for a common kind of flow that you would see in an agent, the LLM router with function calling. So I think you covered most of it there. I'll also say that we have all the code for this as well too, is up in one of our examples. And so we'll add that to the resources so folks can kind of go in and see. But I think it's an interesting one where I think as you get more complicated agents as well too, beyond this, it's like you could find other things that are good or bad with those too. So something we can dive into as we keep going.
And a really good question from Dipanshu here, which is like, do you think, and Jerry, do you think flow engineering is actually going to be a requirement of kind of building these eventually, like thinking about how the agent progresses through the different actions and skills?
Yeah, I mean, yeah.
Yeah.
Yes, my hot take is just that's not that much different than just like learning programming. And if you're good at programming, you can figure out how to integrate it with agents.
Yeah.
And so yeah, like whatever patterns that we impose on you or LangGraph or CrewAI, et cetera, I would just like kind of bear in mind like what exactly is like the logic that I'm defining and what's the logic I'm trying to let the LLM figure out. And I think that really is the key idea of flow engineering. Like how you like write it is just a like syntactically dependent on the framework that you use, basically.
Yeah, and I think like in our assistant, we this is we do have LM routers. We actually have like sometimes there's an LM router and then there's a second router called to even. So there is a thought process that you go through as you're kind of building, okay, where's a decision point I have based upon what the user wants, what I'm going to jump to. Do I need another, like, is there another decision point for some reason, or am I kind of just taking an action on it? And then there's a lot of like, we'll get into it further, but like state management becomes important in that sometimes these skills, at least in our assistant, can take up the whole context memory. So we have like AI search, which uses the whole context memory, which means we can't save that to a message bus because next time if you just were call messages, you'd be out of context completely. So there's a bit of like, what do I save off in state in some of these two, which we'll get to, which is more complex, but this is the simplest idea is that I have a router, I have a skill, and I'm not like stacking too much right now. Someone says kind of feels like in line with BPM. Yeah, so I guess something like that. Code based. So and we're going to go through a little bit of like what this looks like in workflows in true code. This was just set up. I think John, you kind of did a step in the beginning that just kind of set up state and set up some of the stuff around it. So there's not a ton in this example here. Anything else you want to add before we kind of hop to the next one?
No, I think this is just
Okay.
the setup. I'm sure there's a couple optimizations there that could be done as well through the code. But yeah, just the setup there.
Yeah, so getting to the heart of this is kind of like, okay, think of it, I think the while loop idea is actually kind of a good one, and the while loop can iterate back to user input in this case. So you kind of have some user input, some start event, you kind of hit some LLM router, decides where you go, task or skill wise. In this case, I might be querying data, I might be analyzing those results in some way. And so the LLM router is kind of determining your intent and extracting parameters for the skill or action below. Do you want to describe maybe a little of this, John, in terms of like, how the event flow goes? And
yeah, so this is kind of your straightforward function calling example here, where we've got a asynchronous call that's being made in this router step to the LLM router to kind of decide on whether or not to call one of the different tools. And then we'll see in a second, there's a tool call kind of handler that we use. So, but like, this is one of those steps that you get to think of. So when I was kind of mentioning before, we could really go in and just like fully define what the router is going to look like. I have my if else at the bottom, which is just like your basic kind of structured code there. And so that's easy to see where things are going to go depending on the responses you get, which I really like. I think the one thing I would call it is like you kind of, Jerry, correct me if I'm wrong, but a lot of the workflows is designed to work asynchronously. Like it's sort of out of the box will work asynchronously. So I'm using asynchronous calls here and things like that, which I think worked well in our case. But I think there's like, I had a little bit of trouble debugging that in some cases. So I guess I'm kind of curious to hear a little bit more about the thought process of making it asynchronous by default. Like what some of the benefits of that you see are as well too.
Yeah, for sure. It's a good question. I think part of it is, I mean, as John mentioned, you can see this is a single step of a workflow. So it takes in some event, a router input event, and then you define just like what it outputs. And basically the idea is that like we handle like the producer consumer like messaging. So we pass the messages from, whatever events, whatever step is producing these events to whatever like consumer step that's listening to these events. And so like in a way, like it feels a little event driven because it's basically like inherently each step is like its own independent unit that's listening to something and emitting an output. So just like aesthetically, it feels kind of similar to what like an agent or autonomous like function should be doing, like just like listening to some observation and emitting some output. But there's like practical systems level benefits to this. Like basically, again, LLM calls can take a while. It's like, and that's why I think the speed part becomes a higher priority for like an LLM program versus say a normal program without LLM calls. And so if we can just make everything async by default, that means that we can optimize the execution under the hood and basically just like make LLM calls all async so things can happen parallel all at once. And then you don't have to worry about like adding a bunch of like async IO runs like in your LLM calls. So I think that's just something that we made a choice for. And if you look at like event-driven framework like Temporal, where it's like similar philosophy, but just like over like standard kind of like data processing, those types of tasks, like it's kind of similar. It's like we have that base layer under the hood, so you don't have to worry as much about like optimizing execution speed. And then you can still have the flexibility to write other stuff.
Yep. Got it. Anything else to add here, John?
I think actually the only thing I'd call out is just so on the right bottom right here, you see like me defining the events that were used to move between different steps. And so just to kind of make that very concrete for everyone, like that's what you do to define the events that move between things, versus if you're thinking in a graphical approach, the kind of equivalent to the events there is going to be more defining edges that might then have logic on them. So you're actually defining like functions in that case. And so I think one thing to keep in mind is if you're comparing those different kind of what the syntax looks like for those, you're really comparing like essentially like these pedantic event definitions versus a full function that you have to then move between and think of as an edge. So I think it's worth mentioning kind of around the event-based traversal side of things.
Got it. And one other point it looks like to call out here is some of the local state passing occurs through those events. So if you want to pass local state between one step and another.
Yeah, and I know we're going to get into that I think a little bit later on too, but there's like the options of passing it through the events or passing it in the context that's like used by the different steps as you go through. So I think we'll get more into that a little bit later on, but that's something worth mentioning.
Yeah. Yep. And then this is kind of a little bit of the how you handle a tool. And I'll tell you in our assistant, I feel like when I first saw functions tool calling, I kind of thought of it as like, oh, okay, code that, it's just going to be code that we execute and return. And this is like, I'm thinking kind of my original introduction to tool calling. And in our assistant in Arize's Copilot, we actually do a lot in the tool call itself. We call it, like, internally we call them skills. It's just a term that's kind of stuck internally. And the skill might have multiple LLM calls underneath it. So you might do an LLM router plus some number of LLMs that process data. So you might get a couple, a tool call is not necessarily just a calling your local code and returning, but there might be a lot more in this. Just note as you all are thinking about this. And I think even in your example, John, you kind of did a little of that, right? There's LM calls below inside the tool calls to do something.
Exactly. Yeah. Like one of the tools is a SQL generator, and like it'll generate SQL for a table, and then we run that. So there's multiple steps within that, and then queries that happen there too. And I know there's a comment as well, or one of in the chat I see a comment from Depencio about talking about how easy it is to kind of shift existing things to work within the framework or like customize or rebuild parts. You'll kind of notice that, I mean, you have the events moving between different steps, you have the add step decorator, but beyond that, I don't actually think there's really anything that you need to modify within those. It's just how do you move between the steps and then defining something as a step. So that made it sort of easy to actually, it's worth mentioning, when I was creating this, I'd started from a existing no framework agent and then tried to convert it to use these different frameworks. And so converting a no framework agent into a workflows agent was pretty straightforward because it's just adding that decorator and then adding some of those tool calling events or just different events that you might use to move between the different steps.
Cool. Yeah, and so it's exactly it. You want to describe it maybe if this was the SQL event, like the SQL generation, you probably get an event with some parameters from that, or maybe some description of the function, the function or tool call, you're making parameters associated with that, and then you're taking some action here in the yeah, in the callable, this function callable section where I'm actually calling something below. So function call actually does something, returns a result, and that does something can call an LLM can be more complicated.
Yeah, and actually you could do that in the whole way of triggering other events to do that callable, as opposed to what I've done here, just directly calling the function too. It's worth mentioning.
Yeah, got it. And then we did want to kind of like lane graph is definitely is definitely out there and gaining momentum and has some mind share. So I do think we want to, like we're kind of hinting at the beginning with, we did want to lane graph versus this and did want to kind of show them side by side. So this is our goal of just, again, comparing frameworks, talking about like, if you're building it in lane graph, you need to, you think this way. If you build workflows, you think this way. In the lane graph, you are required to kind of build your state machine. It's a little bit of like a state machine to me. And it's like, what nodes do you have? What edges do you have? You need to think of it that way and build that out and define those, which isn't necessarily, hey, listen, I don't want to say it's necessarily bad. You're gonna, it's just another way of thinking about the problem in a different way. But in the workflows case, you're going to be event based versus node and edge based. Anything to add, John?
Yeah, just the one thing to make it really clear is if you're looking at the left side, so both these are doing the same thing, the same kind of agent flow. Left side, that should continue method is an edge that we're defining.
Yeah.
So kind of to make what I was talking about before, the thinking in terms of nodes and edges, like a little bit more concrete, you're like defining the actual if statement logic of how you're going to route within that should continue edge, versus on the equivalent on the right side is going to be more like your the lines around 15 to 18 or so where you're setting up where that route goes. So it's a syntactical difference in how you define it, but I think it's also a sort of conceptual difference in how you're thinking about the objects within your code. So hopefully that makes it a little bit more concrete what we were talking about earlier.
Yeah, got it. So
I also know there's a ton of questions coming through the chat side as well, and the Q&A.
Yeah, feel free
you're jumping in there if you want.
Feel free to call it out. I've just been answering them. But yeah, we should probably bring it out for the broader audience.
Yeah. I think there's some, there's definitely some questions on like, I feel like we were all chatting even before this on like, what does debugging look like? What does observability look like in these tools? And so we're adding, we actually have a section in the back where we talk a little bit about evals on agents, but yeah, I think instrumentation, debugging, all this stuff. We ourselves use our own tools today, every day, many times a day to like debug our own assistant. And the stuff, I do think the current kind of views, like the views around, like typically what we do is we'll unfurl, you talk about that while loop with LLMs in it, and maybe there's multiple LLMs underneath, but typically we'll unfurl a loop and have that be, typically you're coming back to the user at the top of that loop, or maybe you're doing some iterative flow, but when you kind of return back in some way is typically where we unfurl it on our side, meaning that we'll trace through a response, come back to the user, and kind of use the same kind of constructs that we've built out for LLM systems, spans, traces, stuff like that. In addition to things like sessions, which show the full continuing progress of some multi-turn transaction or iterative flow. So I think there's a lot around debugging these that we're all thinking about and building out. But today the constructs work really well, and a lot of what we use are we heavily use the ability to replay something that has progressed through here. So and we there's some stuff in market that's like break on a breakpoint. We tend to just capture the data and replay based upon the data we have. But being able to capture the iterative flows, the loops, and replay is important. Maybe John, at the end, you can pull up Phoenix and show like workflows in this. We can talk through it.
Yeah.
Any other questions in this? So to satisfy condition, okay. So to satisfy conditions of continuing or completing the loop, do you tend to prefer deterministic requirements met or LM decided completion. We've done, I would say most of what we've done, when we were first building, at least, I'll talk about our system, I'll talk about what I see in market. I think most folks are kind of have deterministic kind of steps. It's a little bit simpler than like the just let it go and let the LLM decide when it's done. We attempted to originally allow our system to do like loops and continue on and try to break, and it just added a lot of complexity for not a lot of a value for our use case. Now, I think there's use cases where where that makes a lot of sense, and so I think a little bit more market people, at least right now, are have a little bit of simpler, simpler deterministics probably more often, but you can get a a critique at the end and let it loop until that critique is met or the value is met. In our case, you can build it into the router, you can build it into different steps too. I don't know if anyone else has anything to add, but that's my rough take. Cool. So we did want to do this, like I know we've hit on the router a lot, but this is like the center of what I see, and this isn't just what we do, but what I see in a lot of customer product, customers out there and products is, and it could be layers and layers of routers, but just a concept of, and again, a router is just function calling off of an LLM. There's some entry point on it. There's probably some loop back to it after you've taken your branch. And the router can, this example here as, is maybe doing product search or product comparisons, and the router's handling function calling and basically making really an intent decision based upon a user input. I think we added one note recently. Me and John were debating this note on the router earlier, and I've seen it kind of hot takes from teams, which is like, could I use a simple classifier? Does it need to be an LLM, to do these? And my take is like, I don't think we can make our system work without an LLM as a router. And there's like, I go into our product every day and I see like, I see someone using Japanese, for example. And just the ability to generalize what your assistant is doing to multiple languages, to these outside of use case things that you didn't think about in terms of the routing decision. This, I think it would be very hard to make this all work, at least in what I've seen, unless you have something really simple. And you don't expect a highly varied set of inputs. So I'm much in the camp of like, the generalization really helps. It adds complexity, but it really helps. Okay, so one question is, does Workflows offer a system records or persistence layer for agent workflows? We do have state later on as a point here, but do you want to comment on that a little bit?
Yeah, so we have this concept of like an in-memory session, I think. Basically, when you run a workflow, there's this context object that's passed around. It's in memory. We are working on being able to swap that out as an abstraction for like persistent layers, like for instance with Redis, for instance, or MongoDB. In the meantime, one thing that we see from some other users is like the context object itself is like persistent, is in memory, but you can like basically insert a connection to like Redis, for instance, yourself, and you can just write that to write whatever state you want to Redis, kind of like throughout the course of the workflow execution. But yeah, we're adding some of the like persistent state management features too.
Cool. We'll talk a little bit about state in a minute, at least where it's used, and kind of go a little bit deeper. Again, simple architecture, I won't belabor this, but routing, and of course this could be Anthropic or Google Gemini. User input, some branch, maybe some LLM. This is probably the simplest thing we see in production right now. On the state side, we I'll talk a little bit about what we use in our product and why state comes about, and maybe, and Jerry just kind of elaborated a little bit on what's coming and what's there in workflows right now. But probably local states probably use the most, obviously, and then but there's an idea of global state. And local state was kind of the event stuff that you saw, kind of what's getting passed from kind of either step to step in this case, but it could be function call to function call or node to edge. But for the example I gave earlier, which was a great example, is our AI search skill, which uses the whole context window for an LLM analysis. The result, we can't just store this in like a message bus. We've got to consciously store the result or consciously store the search results, so that we might be able to refine them later. And it needs to be kind of stored separately than messages, because if you feed it into the LLM, it's going to blow the context window out. So whatever those results were, or whatever I was searching on, I might want to use in another step. And so as you're kind of traversing the different skills or different areas within your application, you want to store that off, and potentially use it. And then, Jerry hinted at one of the challenges, which is if this state is persistent. A lot of times you're hitting a web server which maybe doesn't have persistent state. You got to figure out, like, where do I persist, or where do I back it up in, or is it part of, am I persisting into the Postgres or Redis or some of these? So all this comes down to more complicated agents that you might be building, and what steps you might need. We got pretty far without state originally. So like I wouldn't think of if you really need the global state originally, and where you need it. So we ran into it as we got to more complex skills and what we wanted to save off and how we wanted to pass data around. But you bite off the stuff in the chunks that make sense. Don't just jump the cool tech. Would be my 2 cents. So some other questions. Anything you just want to surface up, John or Jerry?
One we can tackle quickly is there's one from Chris earlier. That's, can you ensure the router gets intent right 100% of the time using function calling? Like, just to highlight that one, no is the simple answer there, which is kind of why you might why some people look to use smaller models like a DBERT class or like a BERT classifier, which we don't, which is kind of our take is, or Jason's take is that may not be that generalizable across different kinds of inputs. So short answer is there's not really a way that at least I know, I don't know if you guys know a way to get 100% accuracy around the function calling correct. That would be great if we could do that.
No, you're not going to. But we do function calling evals. So within Phoenix, there's a set of evals for tool calling and tool calling correctness that we run internally on our assistant, and that we use constantly. To be honest, like, I think the thing that I've seen is like it's pretty good at getting intent. Like maybe it's like 90% of the time it's got intent right. The parameter extraction can be a little bit more iffy, where I've seen it kind of mess up a little bit more in extracting the right parameters. But you do want evals on those, and then a lot of the times you can. A lot of times, if it doesn't get the routing right, you're adding instructions. So it's like an edge case you didn't think about that didn't fit into your router's template in some way. And so a lot of times we're adding instructions that like capture something we didn't think about, so that next time it hits it kind of goes the right direction.
Awesome. I see there's a bunch of questions too, Jerry, you're handling the chat around like memory and kind of the concept of connecting to a database, this or memory. Is there anything more that you want to kind of share just around that? I know you've answered some of the chat, but just for the recording as well.
Yeah, for sure. I think some of the questions are around like state checkpointing, which I think we either have or are adding very soon. So if that's something you're very interested in, stay tuned. This is something that we are definitely working on. I think the top level asks we typically hear from users is something around like better state management. So everything I talked about, like checkpointing, persistence, better human in the loop as a service, actually. And so not just like writing a simple like input, function in your notebook where you can like input a command, but actually having an API that can serve and have like the human interrupt workflows. That's something that we're actually working working on. Actually, hopefully we might have a release by end of this week or next for that. And then while everyone's here, and I was just going to type a message in the chat, there are some questions around like deployment in the cloud. And I think some agent features come alive when you actually deploy as a service. And one thing we're working on is like a fully open source repo called Llama Deploy, which basically integrates directly with workflows. So right now, I think when you run these workflows, they all run async in a notebook. With Llama Deploy, you can deploy them as like API services, which allow you to then serve client requests. And I think that offers like an additional layer of like basically both scalability and kind of like interactivity with like an agent, right? So you can start building like agent systems that serve like different types of applications. So I'll drop the link in the chat.
Cool. Lots of I mean, lots of info to build is what it feels like to me. Good stuff though. In terms of the question here, there's one here which we didn't grab on, which is like, do you have approaches for systematic prompt improvements for complex analysis tasks? There are frameworks like DSPy, which take this to extreme, do kind of like MePro optimization, I guess. That's what they're, do you know some less extreme strategies for converging towards instructions, e.g. based on evals, yielding optimal results? So it's a good, really, assuming retrieval is not a problem. So good question. Absolutely. Like I think what we do today, so within Arize, like some of our flows tend to be adding evals to kind of adding evals as we're kind of working through, and we'll talk a little bit about where we break up the evals in these different steps here in a second. Then normally they may at this point there's probably some human annotation that kind of occurs on top of those evals where you're marking certain certain examples in some way, maybe sipping off to a data set. Sometimes we have power, in Arize, we actually have some power tools to find stuff. So we have AI search, which can search across all your explanations from evals, give me all the reasons you think it's failing for this particular step, filter on those, save them off. And then I think what you're typically doing is finding examples that are, different groups of failures. And then you're trying to add stuff to the prompt to do that. We do have prompt optimization, again, which also uses our assistant in product. So you can make changes using again an LLM to do that, or you can just add the instructions yourself within the playground. So in our case, there's kind of workflows that use both human elements, query elements, and then you're adding, there's some AI assistant in all these. But there's still, I still think it's early where you're sitting in your data, marking it, evaluating it, to help you find the examples, and then iterating yourself is probably, there's not a magical optimization step that's an easy button per se. So I love the flexible thought flow, LlamaIndex workflow. I put the print in thinking LlamaIndex. Okay, cool. Thank you. And then there's, this is kind of a simple thing. I mean, maybe John can show, well, John will show some of the, like what tracing looks like, but the way we think about evaluating agents is breaking it up into parts where you should think about, and sometimes some of your tool steps you might not care about. Some of them, if I'm honest with you, like there's some, maybe a human accepts something and you're not so worried about the generation, but some steps of tool steps here are skills you might care a lot about. Like we care a lot about our AI search results. And so building, you're going to build evals in the places that are most important first. You're going to decompose your problem into the places where you can run an eval in the first place. And then someone asked about the router evals. Typically we are looking at, did it get the intent right? Did it extract the right parameters? Those are typically the function calling evals. And then the task evals, for example, in AI search, we're looking at what data came in, what results came out, did it actually find the right results within that task we had. So break up your thing into steps, do evals for each step, and then function calling or intent-based routing evals are a thing to run on top of your router. Cool. John, did you want to share for at least a minute?
Yeah, just show the traces we have
Yeah,
for workflows. Yeah, totally.
and then
Um, yeah, just to quickly show here, we have a bunch of tracing attached. So there's a bunch of questions about like debugging and diving into things from there. So we do have traces that we've captured from that example project that we showed you. And these are all on our Phoenix demo site. So if anyone wants to check it out, you just go to Phoenix and then see in action. You'll see there's a few example agents you can pull from. We've got a couple LlamaIndex demos here. This one shows the workflow side. So one of the things that is helpful is just as you try to go through and look at these different inputs that you're seeing and outputs. I think this is let's show a fun one here. We'll just show this first one up here. So you can see kind of the steps that we're going through with the workflow. So we're going through the steps that I had defined. So I had that prepare agent step. You can see what's the inputs, outputs there, and kind of attach attributes to those pieces. And then you can like look through the router call, getting a chance to see what's actually going into the OpenAI router call that we're making. So in this case, I'm having it generate and run. It's choosing to use this tool, generate and run SQL query. Like, for example, when you're actually building these things, one of the tricky things is a lot of times your router will try to go a little bit further and actually like generate the SQL query for you when it doesn't actually have access to that information. And so just getting to like step into the individual calls as you run this, it's an easier way to kind of see what's happening at those different steps. And then we could attach evals to this as well. So this is where we could attach like a function calling evals, sort of mark whether it was choosing the right function, whether it was doing the right thing from there. And then you'll see this kind of goes to that tool call handler flow that we mentioned. And then in this case, I've got it running an SQL query. So you can see, okay, what's the query that's run? What's returned by that? Just kind of step through the different steps there and then see it actually kind of going back to your LLM, this time with the tool message appended. So this is, you might store the messages in the context and have them get retrieved and passed back. Then it chooses to make a data analyzer call, kind of keeps flowing through there to that analysis tool. This is kind of hard to read, but like this is generating data analysis from that. And you can see the final call it makes to use that data analysis and kind of pipe back to a user. So it's one way to kind of step through all of the info that you're seeing and get to the eventual response and kind of debug each call that's being made and things like that. Whether you do that ad hoc, just like basically when I was developing these agents, I had this running alongside what I was working on and then would go through, run some prompts and then jump over and see if I could figure out where the issue was. You kind of do it ad hoc debugging in that way, or in a more scalable way of attaching evaluations to the data over time as you start to kind of share the agents and get it into production in some different areas. So one of the things I'll call out here is that because it's all built in, like workflows is built within the LlamaIndex kind of framework, all this just gets captured through an auto instrumenter that we have. So it's very easy. It's a couple lines of code to kind of connect these two things, which is really helpful and makes it much easier to actually, I don't know, attach this to whatever kind of agent code that you're running through as well too.
Cool.
All right. Yeah,
Awesome.
just anything else you want to call out within the visualization here?
I think it's great example. Just want to kind of show what unfurling one of these looks like.
Cool.
Cool.
We got some more questions as well.
Yeah, I think we're on the end here. Any other questions in the stat? Let me see. Is anyone using Mem0 with LlamaIndex? What are some good use cases?
I don't know any off the top of my head, but Mem0 I think pivoted to like memory management, right? It's like context, it's like personalization for like long running memory. Yeah, we'll keep you posted. I'm not sure yet.
Yeah. And then another question of, do we have any benchmarking available on how many tokens a typical Llama workflow consumes versus other workflows like auto generating graph? I think it's gonna be a hard one. John, any,
I mean,
obviously it's gonna be kind of execution dependent. But I thought it was an interesting comment from you the other day where autogen, like lots of back and forth, but the back and forth, did kind of improve answers in some cases. So my guess is with autogen, you're going to see more token usage, but maybe some slight improvement in some place, less control.
I think and Jerry, feel free to correct me if you think differently here, but I think with your lower level kind of frameworks where you're defining steps and nodes and kind of either graphical or an event-based approach, you're in full control of what's going into the prompt, and you're full control of like what you're pulling from memory. And so from a token perspective, I think you have the same level of control across either of those kinds of frameworks. Then if you do get into something like AutoGen node, Jason, to your point, you don't have as much control of like exactly the steps that are being followed. So you could have the token count blow out in that case, or just increase.
Yeah, you can literally do whatever you want in these workflows. So like within a step, you can write like whatever Python function you want. So we have core LLM abstractions too, if you want to use that. And then you basically have the ability to customize and measure everything.
Yeah.
We would track all that within the observability tools that we've shown too as well, just to make it clear, like the token usage and all that as well.
Yeah. So I feel like that's that's an interesting one. I do think like the let the agent go iterate for a long time, you do start to worry about token usage. So depending upon that while loop, whether it's breaking on user input or whether you're continuing for some period, whether depending upon how you built your system, you might have differing different feelings. It could be time latency based comparison. I did some benchmarking with a particular use case. Happy to share results. Yeah, like feel free to share in the community. Super interested in what everyone else is doing and what they're seeing framework wise. Cool.
Yeah, Dimitri, I would love to see that as well too. We can connect afterwards. I know you shared through some things, but that would be really interesting to see if there's, because I guess there could be a difference there of the exact kind of flow that's taken between steps, for example, from a latency perspective.
Yep.
I think a general, a question or a thread of comments is basically an interest in kind of agent debugging capabilities. So a quick comment on that is we have some core debugging like functions in workflows that allow you to go through a workflow step by step, right? So it's not like a UI based flow, but like you can write code to just like trace through the execution of like a given run, see what's going on, and then like given that, try to like intervene with your own inputs if needed, just through code. But I think, yeah, there seems to be a general interest in, for instance, being able to interact with an agent execution, maybe through some sort of UI-based interface. And so if you have thoughts there on like what you find the most useful, definitely let us know. I'm happy to collaborate with like the Arize folks, build some like open source tooling ourselves. But yeah.
Cool. Well, thank you for joining us, Jerry. Excited to see all these agents in the wild. And Jerry, any no code agent? Okay, here's one more last one. Any no code agent workflow builder in the pipeline for workflow? Okay, that's kind of interesting.
Yeah, I mean, we're not focused on that at the moment as much because we're still building like developer tools. But maybe in the future, yeah, or we're happy to integrate with like a partner that does this.
Cool. Well, thank you everyone for joining. Thank you, Jerry. Awesome agent. Agents are kind of everywhere these days. So appreciate the perspective and what you're building, and awesome to connect.
Great. Okay.
Thank you.
Thank you. Thank you for having me.